Welcome to today's video, where we'll explore how to set up Google Cloud Composer and take a look at some under-the-hood configuration and Kubernetes concepts. Let's start by understanding what a Google Cloud Composer is. A fully managed Apache Airflow service. While Google takes care of most management tasks, you still have visibility into the system because it runs on a Google Kubernetes Engine cluster within your own project and virtual private cloud. In this video, we'll focus specifically on Composer 2, which gives you more control over low-level permissions and infrastructure settings. It's worth mentioning that Composer 3 is currently in preview and promises to be a more fully managed version with fewer configuration requirements. When setting up Cloud Composer, certain settings are absolutely crucial. One of the most important is the image version. Think of this as selecting the DNA of your environment. It determines two different versions you need to consider. First is the Composer version, which is Google's managed service wrapper. Second is the Airflow version, which is the open-source workflow management platform underneath. Another vital setting is the service account. By default, Cloud Composer selects the Compute Engine service account, but you have the power to change this if needed. This service account serves two essential purposes. It runs the pods in your environment and performs important operations like environment upgrades. When we check the official recommendations for access control in Cloud Composer 2, one crucial requirement stands out. You must ensure your service account has the Composer worker role. While the default Compute Engine service account typically includes this role, it's often beneficial to grant some additional roles to this service account for enhanced functionality. The configuration process offers many options, particularly regarding networking settings. However, if you're following along and want the simplest approach, you can create your environment with just one click using the default settings. As your environment begins to take shape, you can observe the Kubernetes Engine section, where you'll see a new cluster being created. This is a special type of cluster specifically designed for Cloud Composer environments. While Google manages most aspects of this cluster, you still maintain access to it, a valuable feature for troubleshooting and monitoring. Remember that trusty service account we selected earlier? It's now in charge of running this entire cluster. After initiating the setup, you'll need about 5 minutes of patience while your environment gets ready. During this time, it's worth noting that you're getting a regional cluster, which provides excellent reliability by operating across multiple zones in your selected region. Once your cluster is fully operational, you might notice something interesting. There's no nodes page visible in the interface. Even when you return to the Kubernetes cluster's overview, you won't see any nodes listed. This is completely normal because your cluster operates like a Google Autopilot cluster. This means Google's system automatically manages the node pool design for you, making scaling operations effortless. Your cluster can automatically adapt its resources based on whatever Composer jobs you decide to run. The Composer environment provides two different interfaces for you to work with. First, there's Google's custom front-end interface, which gives you specialized views for examining different DAGs, or directed acyclic graphs, and various perspectives on your Airflow environment. Second, there's the Apache Airflow interface itself, which you can access directly. When you open the Airflow interface, you'll notice the Airflow monitoring job already running successfully. You'll have access to all the standard Airflow views you might be familiar with. Now let's focus on what makes this video special. The behind-the-scenes aspects of Cloud Composer that many users never explore. While we've seen how Kubernetes forms the foundation of these clusters, we can go even deeper by examining the Kubernetes objects themselves. We'll do this using the kubectl command line interface. The Cloud Shell terminal offers a convenient way to work with kubectl commands. One of its advantages is that you don't need to set up complex authentication or install additional client libraries. To get started with the Cloud Shell, you first need to authenticate with your cluster using the get credentials command. This command requires two pieces of information: your cluster's name and its region. Once you've authenticated, you have full access to explore your cluster using kubectl commands. If you run the getAll command, you might be surprised to see very few traditional Kubernetes objects in the default namespace. This is normal. The real action happens in other namespaces. When we examine all namespaces, we discover much more activity. In the Composer System namespace, you'll find various jobs running, including agent and initialization jobs. This namespace also contains additional composer-oriented systems and includes a Redis instance that supports your cluster's operations. There's also significant activity from important supporting services such as Google-managed Prometheus for monitoring, the metric server for resource tracking, and DNS systems for networking. The Composer namespace itself is particularly active, filled with core Composer workloads. Interestingly, the cluster even includes support for GPUs, showing how versatile these environments can be. This is where you'll find that monitoring job we saw earlier in the Airflow interface, demonstrating how all these pieces connect together. One particularly useful command allows us to check what kinds of resources this cluster supports. When we examine this, we discover a fascinating mix of different resource types. First, there are the standard Kubernetes-based resources that come with any Kubernetes cluster. Then, we see Google Kubernetes Engine-specific resources, which primarily handle networking functions. Finally, we find Composer-specific resources, such as the Airflow worker set, which are unique to this environment. Understanding this Kubernetes layer is your secret weapon for working with your Composer environment at a deeper level. Every operation in Composer ultimately translates down to this fundamental Kubernetes layer. This knowledge becomes incredibly valuable when you need to diagnose issues or want to explore your system more thoroughly. For example, if you're experiencing problems with your workflows, understanding the Kubernetes layer lets you inspect the actual pods and containers where your tasks are running. You can check logs, monitor resource usage, and troubleshoot issues directly at the infrastructure level rather than being limited to what the higher-level Composer interface shows you. Think of it like having both a high-level map and detailed street-level directions. While the Composer interface gives you the big picture, understanding the Kubernetes layer underneath gives you the ability to navigate the smaller streets and alleyways of your environment when needed. We hope this quick dive into Cloud Composer's underlying architecture has been helpful in understanding how this managed service operates behind the scenes. While you don't need to interact with these lower-level components during normal operation, knowing they exist and how to work with them can be invaluable when you need more detailed insights into your environment. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. Thank you very much for watching to the end, and please enjoy responsibly.